So what we have here are three linear systems, and what we're going to do is we're going to determine the number of solutions that each one of these systems has. It will either have no solution, one solution, or infinite solution. So what we want to do first is take each one of these equations in the linear systems and write each in slope-intercept form to identify the slope and the y-intercept of each line. Slope-intercept form, we want to rewrite this so that it's going to be y equals mx plus b. So we have x plus y equals 3. We want to isolate our y. So we're going to have y equals, now it's a positive x on this side. When we take this and move it across the equal sign, it'll change from positive to negative. So we'll have negative x, and then we have our plus 3. So now we can tell that we have a slope of negative 1 and a y-intercept of plus 3. Next, we'll do the same thing with our second equation. So once again, we are going to write it in slope-intercept form, y equals mx plus b. So we're going to have negative y will equal, we're going to take our negative 2x, move it across where it changes from negative to positive. So we'll have positive 2x, and then we have our minus 2. And we'll make y positive. Take our negative, apply it to the other side, so we'll have y equals negative 2x, negative and a negative make a positive, so we'll have negative 2x plus 2. Now we take a look at the slope of the second line. This is negative 2, and we have a y-intercept of positive 2. So if we look at the two slopes of these lines, you're going to see that they are different. Now when we have two lines with different slopes, that means they are going to cross each other just once on a graph. And we have previously learned that when two lines intersect at exactly one spot, the linear system has only one solution. So this linear system has one solution only. Moving on to the second linear system. Once again, we're going to write this in slope-intercept form so we could determine our slope and our y-intercept. So first of all, the first equation, 4x plus 6y equals negative 10. What we want to do is we want to isolate our y, so we're going to take our 4x, move it across the equal sign where it changes once again from a positive to a negative. So that's going to look like 6y equals negative 4x minus 10. So we'll go ahead and solve for y. We will divide by its coefficient of 6, and we'll also divide the other side by 6 as well. Our 6's cancel, leaving us with y equals our slope, negative 4 6x minus 10 divided by 6. And this can be simplified to y equals negative 2/3 x minus 5/3. So here we've determined our slope to be negative 2/3 and our y-intercept to be negative 5/3. Now we'll move on to the second equation. Once again, we want to isolate our y variable. So we're going to take our negative 2x, move it across the equal sign. That's going to leave us with negative 3y will equal positive 2x now plus 5. And continuing to solve for y, we're going to divide both sides by the y coefficient of negative 3. And our 3's will cancel each other out. We're left with y equals negative 2/3 x minus 5/3. We'll go ahead and compare the two slopes of each equation. So the first equation had a slope of negative 2/3 and a y-intercept of negative 5/3. If we look at our second equation, we have the exact same slope and the exact same y-intercept. So what that means on a graph is they're actually going to be right on top of each other. because they have the exact same slope and the exact same y-intercept. So since they're on top of each other, it's going to have infinite solutions, because every single spot along these lines is a solution. In proper terminology, if the two lines have infinite solutions, we call them coincident lines. Alright, last system, write it in slope-intercept form. So we're going to take our first equation, we want to isolate our y variable again, so we're going to take our 2x, move it across the equal sign. That's going to leave us with negative 4y equals negative 2x minus 1. Continuing to solve for y, we're going to divide by its coefficient, both sides of the equation. The negative 4's will cancel each other out, leaving us with y equals negative and negative. So now we have positive 2/4 x, and we have negative and negative. So we have a positive 1/4. And that can yet be simplified to y equals 1/2 x plus 1/4. So we've just determined the slope to be 1/2 and the y-intercept to be 1/4. The next equation, once again, we're going to isolate the y variable. So we're going to take our 3x, move it across, and that will leave us with negative 6y equals negative 3x plus 2. Continuing to solve for y, we'll divide by its coefficient, both sides of the equation, and our negative 6's cancel each other out, leaving us with y equals negative and a negative make a positive, so positive 3/6x, and then we have a positive and a negative, which is a negative 2/6. And that can be simplified to y equals 1/2 x minus 1/3. Now we'll look and compare the two slopes. We have the slope of 1/2 here, and we have the slope of 1/2 here. So they have the same slope, but they have different y-intercepts. First one has a 1/4 intercept, and the second one has a y-intercept of negative 1/3. So they have the same slope, but different y-intercepts. So that means on a graph they would be parallel. They have the same slope, so they're going to run side by side, but they are going to cross the y-intercept at different spots. So therefore, this linear system has no solution.